Okay, so you've got your Pi Zero set up with a flashed SD card and the operating system on, and when you plug it in, it turns on, you see the lights flashing. You've also got the robot chassis from the first video set up with the motors ready to go. The next step is to actually make it move and use the Raspberry Pi Zero to control the motors and get it driving. So that's what we're hoping to achieve in this video. So in order to get started, you'll need to have this Raspberry Pi. If you haven't got this set up yet, then I refer you to my second video in this series, which will go through just the basics of how to flash the SD card. But if you've already got that, you can carry on. You'll also need a USB charger for that. This one's got the standard micro USB on one side, and this one on that one. You'll also need a controller, a motor controller. This one is, let me find the link for you, a TB6612FNG. They're fairly cheap. This one's $375, and it comes with two of these pins to attach it to a breadboard. And of course you'll need a breadboard as well, which this will slot into once you've got the pins attached. You only need one of these because it will drive. This one drives two motors from the one board. But it might be worth, if you see a deal with two of them, it might be worth getting a backup, because I did manage to break one of these by applying the wrong voltage. So just be wary of that. You'll also need the robot chassis from the first video, constructed with the wheels and the two motors. If you haven't done that yet, then go back to the first video. You'll need a charger, a USB charging board. This one is the PowerBoost 500 charger, and essentially it allows you to plug in a micro USB and either charge a battery or discharge the battery. We're going to use these to power firstly the motors, and secondly the Raspberry Pi. You won't be able to use the USB stick plugged into your laptop or your power unit if you want it to be mobile. So this will allow us to be mobile. You'll need two of these. I've got two here. You'll see that this one's got a USB attachment on it. This was soldered on. I soldered this one on. You probably will need to solder one on later, but for now you can choose whether to solder it on or not. It's completely up to you. And you'll need two USB cables to go along with that. So one, you can use the one that was used for the Raspberry Pi, but you'll need another one in order to power it as well. You'll need two batteries, one for the Raspberry Pi power and a separate one for the motor power. I understand that if you try and use the same power source for both, then you might have problems powering your Pi. The fluctuation of the power going to the motors means that it could cause your Raspberry Pi to restart or switch off, and that's obviously not what you want. For these two I've used, I don't think you can see that, but I've used the 1200 milliamp hour 3.7 volt version and the 500 milliamp hour 3.7 volt version. I will post links if anyone's interested in these specific two. It shouldn't matter too much, I don't think, as long as you're able to provide minimum requirements for the Pi Zero. I don't know what that is off the top of my head, but this 3.7 volt supply does work. And you'll need to check that your whatever battery power source you're using also manages to power the motors on your robot chassis. And then you'll just need some jumper wires as well to plug everything in. This allows you to connect things to the breadboard and back, and a soldering iron. And you'll need some solder, obviously, once you've in order to attach the pins to the motorboard. You'll need to solder them on. You'll get your motorboard like this, with the pins separate, and you'll need to solder them on. Here's one I soldered earlier. I soldered it in that side so you can see the labels more easily. I should probably mention as well that if you solder the headers onto your Raspberry Pi Zero, then it makes adding the wires a lot easier, similarly to how the motor controller is wired. Okay, so the first step is to attach the motor controller to the breadboard so that we can start wiring this up. Doesn't matter where you put it. I'm going to put it at the top here, but just make sure that it's spanning the divide in the middle so you've got the use of both sides separately. This is a view of all of the contacts for the motor board. You can see on the right, the top one is VM, that's the voltage for the motor. VCC is the voltage for the circuit. And you got the grounds, you got 3 grounds on the board, they're all connected, so it doesn't matter which ones you use. A0, A1, A02, B02, B01. Those are the outputs for the motors. So first output, the first motor, second output, the second motor, second output, the second motor, first output. So each one has 2 outputs. And then similarly, they both have 2 inputs. The A motor has 2 inputs here, and the B motor has 2 inputs here. These 2 inputs are going to go directly to the Raspberry Pi. That's how you can control whether or not a motor is turning. And these 2 inputs are also going to go to the Raspberry Pi. That's the second motor. And then all of the outputs of the motor are going to go directly to the motor itself. Just a word on that. I have soldered a couple of jumper wires onto this motor, onto each motor cable, to make it easier to use with a breadboard. You can choose to do that, or you can use the existing wires. It's just a bit easier if it's got these extensions on. As well as the motor inputs, the motor outputs, and the power we talked about on this side, we've also got PWMA and PWMB. That controls the speed at which the motor rotates. So we'll also need to attach those to the Raspberry Pi. Oh, and there's a standby as well. Essentially, if that's being powered, then I believe standby is on, and if it's not, it's off, or it's the other way around. But either way, that allows you to put the motors in standby and make sure they're not turning. So we'll need to connect that to the Raspberry Pi too. So let's start hooking these up. Firstly, I'm going to treat this side of the power of the breadboard as the motor voltage, and this side as the circuit board voltage. So they'll be separate, and we make sure we don't confuse the two. So let's get our first power board. Now this is the one I'm going to use to power the Raspberry Pi. So let's just check that works first of all. I've soldered on the USB extension to this one. So let's plug in the USB cable. It's just a standard USB charger cable, and then get our Raspberry Pi with the SD card already in, and then plug the end of the USB cable into the power socket on the Raspberry Pi. And then once you've got that, we'll take our battery, the smaller one we're using to power the Raspberry Pi, and plug it into this socket. And you should see a blue light go on. That's good news. And if we go over to the Raspberry Pi, don't know if you can see that, but we can see the little LED there is flashing, which means that the Pi is booting up. It all appears to be working. Now I'm going to disconnect the power for this, as I don't want to have it on whilst I'm wiring things up. But we know that for future reference, that's now working. Now then, to get the power for the Raspberry Pi Zero, I can't remember which way around I was doing it, but I'm going to do this one now. I need to do one of the power outputs on the Pi Zero to this power row on the breadboard. Actually, I'm going to unplug this power USB cable altogether to get out of the way for now. So we're going to need to find out the power output pin from the Raspberry Pi Zero to power this breadboard chain here. So I've got an image here which shows where the power outputs come from, or what all of the Raspberry Pi Zero pins mean. I think they're called GPIO pins, and this is a description of all of them. As you can see, there's a key here, and the red pluses are 5 volts, the yellow ones are 3 volts. We're going to use the 5 volt output, which is, if I line up the Raspberry Pi, it's the top left with the pins facing the top. So top left is this one here. I'm going to plug in my jumper wire, and then into the plus side, I shall do this end of the power chain. Now we also need the corresponding ground or negative. So I'm going to plug that in, and I'm going to plug that into the ground pin. The horizontal line there is a ground pin, and that's the third one down on the top row from the left. 1, 2, 3. plug that one in there. Okay, so we've now got, or once we've got the battery, and we'll have a 5 volt power source coming down this chain. Now the next step is to supply that power to the circuit board. Okay, so you have the power going from the Pi to the line in the breadboard, power line in the breadboard, and then going out of the breadboard to the VM pin on the motor controller. And then you want to attach the ground, which is the third one down on the right. And the third one down the right is the ground, and you want to put that on the motor board and back to the minus or the ground chain on this. So now we've got power going from the Raspberry Pi to the breadboard into the motor controller and then all the way back again. And then we're going to use this guide here to map the pins on the Raspberry Pi to the pins on the motor controller. And we're going to use a bit of code from this website as well. I'll put the link in the description. You can see standby is pin 13, and then the motor A pins, the motor B pins, all mapped to pins on the Raspberry Pi. You can see there's 2 types of pin here. There's the numerical pin, which is in order going from up and down the Raspberry Pi pin out. And there's also the GPIO pin, which is the Pi reference, which I'll explain a bit more using this diagram. You can see that you've got the numerical pins, which go 1, 2, 3, 4 all the way down to 39, 40. And then you've got these other numbers here, which are the GPIO pin outs. When you're referencing a pin in code, you tend to use these GPIO pin numbers instead of the actual pin on the board, but sometimes it can be useful to reference the pin number when you're trying to find out which one to use. So if I go back to this, you can see the first one on the list is standby, goes to pin 13. If I count down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, that's pin number 13 is the 1, 2, 3, 4, 5, 6, 7th down on the bottom row from the left. So I'm going to take another jumper wire, find the 7th down on the bottom row from the left. 1, 2, 3, 4, 5, 6, 7. And this is my standby. And then I plug that straight into the standby pin on my motor board. The next one is the motor A, so I'm going to plug in the first motor here. You can see the PWMA goes to pin 7, which is the 4th down on the bottom row on the left, from the left. And this one goes into PWMA. This controls the speed at which the motor A is rotating. I'm not going to do every single one of these, but you get the idea. We're going to go down this list and connect all of the motor board inputs to the pins on the Raspberry Pi. Okay, so the next step is to plug in the motors on this motor chassis. Now you should have 2 sets of outputs, inputs here. You've got a red and a black wire for each motor. So this corresponds to the positive and negative terminals on the motors themselves. And on this motor controller board we've just been working with, you can see on the right hand side, as we discussed, there's A outputs and 2 of them, and two B outputs as well. You can choose whichever motor you want as A and as B. I'm going to use black as 1 and red as 2, but I don't think it matters which way you do it as long as you're consistent. First thing I'm going to plug the A01 pin into the black terminal of one motor, and the A02 with the red one, and similarly with the other motor, the B01 is black and B02 is red. Now I've put this upside down just so that hopefully when it does start turning, it's not going to run off the table. Right, just a quick point. I've noticed that I actually put the wrong voltage into the VM pin on the motorboard. You should, just to reference, you should be the voltage from the Pi should be going into the VCC pin on the board. So we got the power coming out of the Pi via pin 2, I believe that is, going into the plus on here, going all the way up the chain, and then the red one, or the positive voltage out of here, should be going into the VCC pin on the board. So make sure you've got that correct just before continuing. I'm going to correct mine now. So the next thing you need to do is think about the voltage for the motors. Now, as I mentioned previously, you're going to need another battery for that and another battery controller board. Otherwise, you'll find that the voltage being drained from the motors will affect the running of the Pi. Now, eventually I'll solder on some jumpers onto this other voltage board, but for the time being, I'm just going to use two of these jumper cables. Stopgap. So I'm going to put the red one into the, actually I'll use the 5 volts on the left-hand side, this side. Actually, I think, yeah, it might be easier to use some pins. If you've got any spare jumper pins, then this was going to make things easier. So we can put it into the breadboard instead of having to try and rely on the pins staying in the board. Okay, so I've plugged in the powers for the motors into the 5 volt and ground pins on the battery board. So the red one is going into the positive line on this side, and the black one is going into the negative line. And so the positive is going into the 5 volts, and the negative is going to the GND, which is the ground chain. And then here I've got the positive going into the VM pin on the motor board. That's the voltage for the motor. And the ground is attached to one of the 3 grounds. I think I used the bottom one on the left hand side. So we've now got power going into the motor board and back out again. The next step is to start programming the Raspberry Pi to control. We won't attach our batteries yet because they'll just drain power, or there'll be a risk of shorting, so I'm going to leave them disconnected for now until we've got our Pi programmed. Actually, having said that, we're going to need our Pi in order to program it, so I'll plug that in now. So you want to use the small battery for that one, and you'll want to use the power board that has the USB attached, because the end of the USB, the micro USB part, is going to go into the power in on the Raspberry Pi, on Pi Zero. And then when we attach the little motor, the little battery, you'll see a blue light come on to indicate power is going into the power board. And then you should see, there you go, a little a little LED coming up on the Pi Zero to indicate that that is powered on. And once you've got power, it'll start booting up. It shouldn't take too long. The next step is to find out the IP address of your Pi Zero. Now the way you do this will change depending on which router you have and which internet connection you're using, but I will show you how I've done it. If you have a different setup to this, then you can search your router or Google the model of your router or the internet connection you have, along with find IP address, and you should find a guide on how to find an attached device. So I'm going to go to my browser, and this is a list of my network, my connected devices on my home network. Now you'll see that in my case, the router has an address on the back, which you can type into the address bar, the URL, and it'll take you to this configuration page. It's under Home My Network for anyone that's got a BT Smart Hub, as I have. And then you've got a list of all of the connected devices, both Wi-Fi and Ethernet. If you scroll through those, one of them should be called Raspberry Pi. If you've just got a single Raspberry Pi connected, it'll be that one. Make sure you know which one it is if you've got multiple ones. And then next to that you'll have IP address. If you're really struggling with this step, then it is possible to find the IP address of the router by plugging in a screen via the mini HDMI and a mouse and a keyboard. But it's much quicker to just load up your router configuration screen if you've got that as well. So make a note of the IP address. In my case, it's 192.168.1.118. And then you'll need to download a bit of software called PuTTY if you haven't already on Windows. As I said, I'm on Windows, but if you're on Mac, then you can SSH directly into there's a built-in SSH client in the Mac terminal, but I'm going to show you how to do this on Windows. I'm sure you can Google it on Map if you so please. Once PuTTY is installed, you'll be presented with this page, which prompts you to type in the host name or IP address. I'm going to type in 192.168.1.118 and leave the default settings. It'll be port 22, which is the SSH port, and select open. And if it's connected, you'll see login as. If there have been problems, then it might time out. If you've got a timeout, it usually means that for some reason your Pi is not connecting to the network. So check the LEDs on and check that the SD card has got the correct Raspbian installation on there. Once you've got this prompt though, you can type in Pi, which is the default user, and the default password is Raspberry, just one word, lowercase. Obviously you want to change the default password if you take this any further, because you don't want people to log in. And then you should get this prompt, Pi at Raspberry. So now that we're connected to the Raspberry Pi, we can start doing some Python coding. The purpose of this is just to test the motors, make sure they're turning properly. We're not going to do anything fancy. So I'm going to use Nano as my text editor, just because I'm more comfortable with that. You can use something else if you prefer, but to start Nano, I'm going to type Nano followed by the file name. In this case, I'm going to call it motor test simple.py. And then you'll go into the Nano interface. You'll see some commands down the bottom if you're not familiar with them, but I'll tell you all of the ones you'll need. And the first line you need is this, and then next you need to import the modules that we'll be using, and those will be time, because we'll need to tell the motor how long to turn for, and you need this module, which is the way that you tell the Raspberry Pi how to communicate with the output pins, the GPIO pins. Next, you need to declare which mode you're going to use for the GPIO board. There are two modes. One is the sequential order of the pins, going from the top left 1 to 40 in the bottom right. The second mode is the custom GPIO pins, which is a bit more confusing. You can use either, but I'm going to use the sequential mode in this case, which is GPIO.board. And then we're going to declare which pin is associated with which function for the motors. So the first one is connected to the PWMA1 pin on the motor board. That is pin number 7 sequentially from the top, and that controls the speed of the first motor. I'm going to list all of these out and speed it up so that you can see it at the end. Okay, so we have the speed of the motor A, PWMA, the two inputs for motor A and on pins 11 and 12, the standby on pin 13, we've got the two motor B inputs, and we've got the speed or the PWM for the second motor. Now next you need to actually do something with this data. So what we're going to do is we're going to drive motor A clockwise. So here we have the two A inputs. We set one to GPIO high and one to low. And And similarly for motor B, we've set one to high and one to low. If you wanted to send the motors around the other way, you could do the opposite and it would turn the other way. Next we need to disable the standby. Next we're going to set the motor speed. So here we've set the motor A speed output, PWMA, to high, and on motor B we've set the GPI output 18 to high as well. So we've put both of these motors to the maximum speed. And then the last thing we need to do is disable the standby. Remember, when the standby is on, none of the motors will run. And you give a GPIO high signal to pin 13, which will disable the motors and allow the motors to turn. Enable the motors, disabling the standby, and allow the motors to turn. I'm going to change this because I've realized that it's a bit misleading. Drive motor A clockwise. This is actually driving the entire robot clockwise, not just the motor. It's setting motor A to go in one direction, motor B to go in the other direction by the positive and negative pins, in this case 12, 11, 15 and 16 in the reverse directions, and therefore the robot should turn clockwise. Now the last thing to do is just to reset the GPIO pins. So what this does is set all of the outputs of the previously defined pins to low, so that when we've got no voltage coming out of them and everything is correctly turned off. Now once you're happy with all of this, hold Control X and it'll ask you if you want to save the file. Press Y to do so, and it'll confirm the file name, and press Enter to go and save it. Now the next step is to test it, see if we get some response from our motors. I realized that I was missing a line in my code, so just before we go any further, make sure you go back to PuTTY and type nano motortestsimple.py. You press up if that was your last command, and enter just to go back into the script, and scroll down. What I found out was we're telling the motor to fire. We're telling it to send output through all of these different pins to make them turn, and then we're immediately disabling them. So what we need to do is add an extra line here, time.sleep, and we'll say 5, which is 5 seconds, and that allows the execution of the script to stop for 5 seconds before resetting all the pins to 0, and that way it should turn. So Control X to save, yes, and then enter, Y, and then enter to confirm, and you get back to your command prompt. And now, if we just check that we've got all of the batteries connected, you should see blue lights on both of the the power boards, and just double check that all of your lines are connected. Make sure that there's a light on the Raspberry Pi as well. Obviously there will be if you've just managed to change the code. And also, just worth mentioning that I've had a few problems with a connection between the volts on the power board here, connected directly to the breadboard. I'd actually recommend soldering those first, which is something I might do later, just to make sure that you don't lose the connection there. So once you're happy with everything, go back to PuTTY and type Python motor test simple.py and then enter. There we go. You see the wheels are turning. Seems like we've got a bit of a loose connection here, which I'll need to fix, but the fundamentals are here. So next I'm going to solder this in, make it a bit safer, make it more secure, and then the next step is to use a BlueTack to attach all of the various components onto the robot so that it can actually be mobile. So there he is with all of the wires and breadboard slotted on, stuck in with blue tack, and all the batteries charged and ready to go. If I focus on that and I just run the Python motor test simple.py, press enter, there he goes.